Hey, good morning, guys. Today I'm going to show you how to read and create something called a cladogram. So I'll put this link up here for you to let somebody else probably better explain it than I can, but I wanted to give it a go. Okay, these are actually pretty easy. What they do is they show organisms, and it doesn't have to be animals, it's just the one that we're most familiar with. Okay, usually the one that is the most primitive is on this end, okay, like the least advanced, and the one that is the most advanced would be on the right side. Not all the time, okay, but the majority of the time. Think about you're reading it from left to right. Least advanced, most advanced, okay? And then if they're all up here in a straight line, that means they're still on the planet, so they still exist, okay? And then what you do is you actually put characters that separate these animals in between here. Okay, so as an example, what separates the perch group from the salamander group is the fact that the salamander has lungs, okay, and the fish does not. All right, if that makes sense. Now, that also means, though, that everything above this has to have lungs. So that makes sense. The lizard, the pigeon, the mouse, and the chimp all have lungs. Okay, so let's try another one. Claws or nails. Which group has claws or nails? We'll just draw this all the way up if you have to. Okay, that means everything to the right of that has claws or nails. Everything to the left of that does not. That's how a cladogram works, okay? Now, the reason the starfish is up here is, and if you know anything about, like, the animal kingdom, the starfish is the last animal that is an invertebrate. That means she does not have a backbone. So, therefore, this would be the ancestor to all of these, okay, that do have a backbone. All right, so let's give this a try. So what you normally do is if you have a chart, okay, you either put X's or ones or zeros or check marks in there, and then the one that has the most check marks is the most advanced. The one that has the least is the least advanced, and there you have your left to your right. Okay, so let's look at these four animals here. We have a shark, a frog, a kangaroo, and a human. Okay. Do all of those have vertebrae? That means, do they have a backbone? Well, the answer is yes. I'm going to put check mark here, check mark here, check mark here, check mark here. Okay? All right, the next one, 2 pairs of limbs. All right, that means they have like a front set and a back set. Not all sharks have that. Okay, a hammerhead only has, not a hammerhead, a sawfish only has 1 pair. So, does a frog have 2 sets of limbs? Yes. Kangaroo? Yes. Human? Obviously, yes. Okay, now mammary glands. That means they feed their young milk, so in other words, they're going to be a mammal. I don't see a shark or a frog feeding their young milk, so that would be the kangaroo and the human. Okay, and then the last one here, a placenta, that means the baby forms in a sac, for lack of a better word. Kangaroo is a marsupial, so it does not have a placenta, but of course we do. Okay, so y'all, they're not always going to be like this, but this shows the order, right? The shark's going to be first, the frog second, the kangaroo third, and the human last. Okay, so what you do is you take yourself a diagonal line, okay, and then you're just going to put them in this order. So let me put the human here. Actually, let me move this down a little, okay? Human here. Come on. Okay, kangaroo here. All right, the frog here and the shark here. And I'm trying to put them along the same level because they're all still alive, okay? Then you need a line, right, for each one. Okay, sorry they're not straight, guys. I don't have the right tools out here. All right, and then you need something that separates each group in between here. Okay, so what separated the shark and the frog? Well, that would be 2 pairs of limbs. 2 pairs of limbs. Okay, so we'll put that here. All right, then what separates the frog and the kangaroo is mammary glands. Okay, so I'll put that here. All right, and then what separates the kangaroo and the human would be the placenta. Okay, so there's your cladogram. Now we're missing one here. It's vertebrae. So since it applies to all 4 of them, where do we need to put that? That means it would actually go here, right, before that. Okay, and we're going to type vertebrae over here, even though I'm running out of room. All right, that makes sense, right? So there's your cladogram. Pretty easy to read. The shark has been on the planet the longest. It's the most primitive. We've been on here the least amount of time. We're the most advanced. All right. Okay, so let's practice actually putting the derived characteristics in the spot. Okay, so let's do some easy ones first. Which ones are the first organisms to actually have true wings? That would be the fly, right? So that means F would be the appropriate letter to put here for wings. Okay, all right, 6 legs, no legs, 8 legs. Ant has 6, grasshopper has 6, fly has 6, dragonfly, butterfly. So that means a good spot for 6 legs would be here at C. Okay? All right, now segmented body. That means they actually have, where you can tell, a head region and a butt region. All right, so all of these organisms actually have segmentation, like they're divided. So that would be a good characteristic for A. Okay, double set of wings. Well, the fly has 1 set. There's 2, there's 2. So that sounds like G would be a good spot for double set of wings. Okay? All right, now how about jumping legs? There are some spiders that can jump, okay, but very few. Ants cannot jump. So the best thing that distinguishes the ant and the grasshopper would be E, the jumping legs. So we're going to put E here. Okay, and crushing mouth parts is actually D. Ants crush their food, their jaw moves side to side, unlike ours. Okay, the next one's easy. The first place where legs actually show up is at the spider, so then that would be a good spot for us to put B. Okay, and then curly antenna, which gives them much more sensation, would be obviously the butterfly, so that would be H. Okay, so that's an example of how you do the derived characteristics. All right, so guys, I'm going to skip this one because I actually want y'all to do this one. I'm going to put it in a Google Doc or a Google Form or a Google Draw something. Okay, so I'm going to get y'all to do that one. All right, I want to show you another way they do it. This is more for like computer people. They use it like bits and bytes kind of. They use a 0 if you don't have it, and then a 1 if you do have it, and then they add the characteristics up this way. Okay, this one did it different instead of having them on the side or whatever. Okay, so you notice how chi here, whatever that made up thing is, has none of these characteristics. So obviously this one's going to be the one on the left. And then the one that has the most characteristics, which I think is going to be tau here. I think, I didn't add them all up. This would be the one all the way over on the right. Okay, and they did this one this way too. Okay, so see how hair, the leopard is the only one who has that. The amniotic egg, the leopard and the turtle. So see, and then you've got this in order here, the same way, and there's your characteristics. Okay, they just arranged it a little bit differently. All right, so I want to mention this. I've actually seen these on the exam some. Notice there's no animals or plants or anything up here, but these letters represent organisms, okay? Now, I want you to notice that the only ones that are still on the planet today would be these up here, D, B, and C. So X, A, and Z are ancestors to these, but they're no longer on the planet, okay? So where they fork actually shows you a common ancestor. So if I asked you who was the common ancestor between B and C, the most recent common ancestor would be X, because that's where they fork, okay? If I ask you about A is an ancestor to B, C, and X, but not D. See how D is not connected to A at all, okay? Now, who is the common ancestor between all of these? Just go down to where all their lines meet, and that would have to be Z. Okay, so Z would be the common ancestor to all of these other organisms. All right, and this is what Darwin was trying to prove the entire time. Okay, all right, so guys, here's another one, and I'm going to give you that one to practice also, so I'm going to actually skip that one. Okay, so cladograms are pretty easy. I might use some of these too, so I'm going to skip that as well. Okay, but I do want to show you that sometimes in the modern society, of course, we use biochemistry, which means DNA or certain proteins. Sometimes they do it by similarities. Okay, sometimes they do it by differences. So see how the chimpanzee, they say for this one protein, y'all, is 100% the same as us. So we would be most closely related to the chimp than the corn right here. Maize is corn. But for this one particular protein, we have 66% similarities with that protein. Okay, and then sometimes they use differences. So obviously here the smaller number is better. So between us and a monkey called a macaque, we have 8% differences only. So that means we're 92% the same for this particular hemoglobin is what they're looking at here. We're 32% different than a dog, 45% different than a bird. Okay. And then the lamprey, which is the ancestor to all of us, actually, we have over 120 differences, or 125 differences. Okay, so those are the way those work. And we'll do a lab on this when I see you actually in person. Okay, all right, so cladograms are pretty easy. Give the Google form or the doc or whatever I decide to attach with it a try, and make sure you email me if you have any questions. Okay, thank you. Have a great day.